Hey everyone, let's finish example 3 from class. Remember, we were finding the centroid of this region. We found x bar, and we did note that there was symmetry about the line y equals x, so y bar really should be the same as x bar. It should be 9/20ths, but let's just make sure. Okay. So y bar is going to equal integral divided by an integral, right? Integral from 0 to 1, 1/2 of, remember, it's the moment of the square root of x minus the moment of y equals x squared. So it's going to be 1/2 times root x squared minus x squared dx. And remember, we're going to be dividing this by 1/3, right, which we're getting from here. Okay? So when we do this, we're going to get the integral from 0 to 1 of, I guess it's 1/2 x minus 1/2 x to the 4th dx. And I guess really what we could do is we could multiply this integral by 3 instead of dividing by 1/3. Right? And then when we do it out, we're going to get, I guess that's 3/2, right? Pull the 1/2 outside the integral, right? Times 1/4 x squared minus 1/10 x to the 5th, I guess it is. 0 to 1. And if we continue that up here, I guess we're going to get 3/2 times 1/4 minus 1/10, right? You plug in 0, it's going to be 0. So 1/4 minus 1/10, that's going to be 5/20ths minus 2/20ths, which is 3/20ths. And sure enough, right, we get, so we get 3/20ths, let's see, 1/4, 5/20ths minus 2/20ths. I think it should be, let's see, 3/2. Oh, whoops, I'm sorry. I'm off by a factor of 1/2 here. I think this was really just 3 right here. 3. Right, so this really should just be 3. So it's going to be 3 times 3/20ths, which equals 9/20ths. So x bar, y bar equals 9/20ths, 9/20ths, right? So actually it was kind of nice that, we knew that we should be expecting 9/20ths, that we had that symmetry, because I was able to find a little mistake, right? All right, let's go ahead and knock out example 4, right? We know that the x-coordinate is supposed to be 0, right, for the center of mass, right, because the region's symmetric about the y-axis. Let's just show it anyway, just to be crystal clear. X bar is going to equal the integral from, well, I guess we ought to figure out our bounds first, right? No, I guess we don't actually have to, do we? Right? Because they told us what they were. -2 and +2. So I guess we can just say x bar equals the integral from -2 to +2 of x times x to the 4th dx divided by the mass. Okay. When we do that out, we're going to get 1/6, right? It's going to be x, x to the 6th. And I guess it's divided by, 1/5, x to the 5th from negative 2 to 2. Here, this is negative 2 to 2. And I think you'll see that you're going to get 0. Okay? Pretty straightforward. Okay? But again, on exam, you would not need to find x bar. You would not need to do that. Okay? Now, to find y bar, and usually a little bit more involved, but I think we'll be okay. I'm going to put the 1/2 outside the integral this time. Why not? And we're going to have here x to the 4th squared dx. Okay, well, that's just x to the 8th. And I think we can do that one in our head. Oh, and I guess it's divided by, what's that going to be? 32 minus a fifth. So it's going to be divided by 64 fifths, right? This is 64 fifths. I'll highlight that real quick. Okay. So we're getting 1/18 x to the 9th. And I guess when we do that one out, I guess I should say divided by 64 fifths. And I guess when we do this out, not going to be the nicest thing in the world, but we're getting, what is that, x to the 2 to the 9th is, I think, 512. Times 2 is 1,024. You can divide that, you can cancel out a 2, so I think you get 512 ninths divided by 64 fifths, or times 5/64ths. And this is 2 to the 9th. This is 2 to the 6th. So I think we're left with a 2 to the 3rd, which is 8. And so this is going to give us 40 ninths. So x bar, y bar equals 0, 40 ninths. That's how you do it. Remember, don't worry about example 5, doing stuff with respect to y. It's analogous. You sort of flip everything, but we're not going to worry about that for the exam.